We are going to learn about quadratic equations with two variables. We're also going to graph an example of such equations. So we have already been introduced to quadratic equations with one unknown. We know the general form of them looks like ax squared plus bx plus c, and on the other hand, on the other side of the equation, we have 0. An example of this with numbers is like 2x squared plus 5x plus 7 equals 0. So in here you can see that c is 7, b is 5, a is 2. Now we are going to get introduced into quadratic equations with two variables. So take a look at this one. For example, x squared plus 2x plus y equals 10. So first of all, this is a second degree equation because the largest exponent of any unknown in this equation is 2. And it has two variables. One of the variables is x, the other variable is y. Let's see another example. Y squared plus x equals 1. Again, second degree equation because the largest exponent of the unknown is 2. And there are two variables. So it's a second degree equation or quadratic equation with two variables. How about this one? Look at this one. X times y plus x minus y equals 2. What's the degree of this equation here? We know y is to the power of 1, x is to the power of 1. X times y, each one of them has the power of 1. So is it first degree equation? No, it's not. So what is the degree of this equation? To answer that, we have to ask what is the largest exponent of the unknown in this equation. So for x, this x alone here is 1. For y here is 1. But what about this x times y? Individually, they have a power of 1. But when we wanted to measure the degree of the equation, we consider the terms that are multiplied by each other. We add up their exponents. We consider the total exponent, the sum. So 1 plus 1 equals 2. So therefore, this is a second degree equation. This is a quadratic equation as well. If it was looking like something like this, x squared times y plus blah blah blah, then this term will make it third degree because the sum of the exponents of the unknown that are multiplied by each other, x squared multiplied by y. So the exponent of y is 1, so 2 plus 1 is 3, therefore it is third degree. So all these were examples of quadratic equations or second degree equations with two variables. Now let's see an example of how to graph one of these second degree equations with two variables. We're going to graph this one. X squared plus 3x minus y equals 5. So we have a table here. One side, one column is x, one column is y. And as we going to figure out points from this equation, we're going to simultaneously graph them. On this horizontal axis is going to be the x values. On the vertical axis, they're going to be the y values. And we chose that to be like that. So this is just a contract. We decide to put x on the horizontal axis and y on the vertical axis. There's nothing we can do in reverse, but that's the most common way. Okay. This is the most powerful way of graphing any equation. You just figure out different points from this equation and pinpoint them on the coordinate system, on the x and y axis. This is a very powerful method. So since we're dealing with a quadratic equation, it is easier to first give a point to x and then find out the corresponding value of y. If you do it in reverse, it could be more challenging. For example, if I say, what is the value of x when y is 0? Then I will have to basically solve a second degree equation with one unknown. We're going to demonstrate that. So let's substitute y as 0. So we get x squared plus 3x minus 0 equals 5. Then I'm going to simplify that. X squared plus 3x equals 5. Subtracting 5 from both sides, I get x squared plus 3x minus 5 from the left hand side equals 5 minus 5 on the right hand side, so I get 0. So I have now converted into the general form for which we have a formula to solve this kind of equation. The formula is x equals minus b plus minus b squared minus 4ac over 2a. So now we have to figure out what are a, b, c. So from this equation, we know a is 1, the factor that is multiplied by x squared. B is 3, the factor that is multiplied by 3. And c is the lone number, which is negative 5. So I substitute these three into the formula. And I'll get x equals minus 3 plus minus square root of 3 to the power of 2, 9. 4 times 1, 4 times a. So minus 4 times 1, which is 4. And then times c, which is negative 5. Over 2a, 2 times 1. Okay. Let's simplify this. So you see it takes more time if you give a value to y and then you try to find x. It takes more calculations, but we're going to do this just for demonstrating. Negative 3 plus minus square root of 9 minus 4 times 1 is 4. 4 times negative 5 is negative 20. Okay. Divided by 2 times 1 is 2. Continuing simplification. Negative 3 plus minus square root of 9 minus minus 20. Minus times minus is positive. So 9 plus 20, that's square root of 29 over 2. So we get two answers. One answer is minus 3 plus square root of 29, which is roughly about 5.4 divided by 2. The other answer is minus 3 minus square root of 29, which is again roughly 5.4 divided by 2. So one answer is about 1.2 and the other answer is about negative 4.2, roughly speaking. So these are the two values we get for x. So when x is 1.2, y is 0, or when y is 0, x can be 1.2. Also, when y is 0, x can be negative 4.2. Now we're gonna do the reverse, because if we put x and we find a value, the corresponding value of y, that's gonna make it much easier for us. Much less calculations. You know why? Because in that way instead of solving a quadratic equation, we just have to solve a linear equation, because you give a value for x. So x in this equation has the power of 2. So that will get eliminated. That will get just turned into a number instead of a variable. Okay, let's see. And usually the easiest value to give first to start with is 0. Let's substitute x as 0 and find out what y is. So I'm going to say 0 to the power of 2 plus 3 times 0 minus y equals 5. Nice. 0 to the power of 2 is 0. 3 times 0 is 0. So we get negative y equals 5. So I'm going to multiply both sides by a negative 1 to get rid of negative y. Turn it into positive y. So negative times negative, positive y equals negative 5. So when x is 0, y is negative 5. That's great. Let's give another point. And by the way, as we giving points simultaneously, let's show them on the graph. So I'm going to show these on the graph. Point y equals 0, so it lies on the x-axis, and x is 1.2. So here's 1, over here is 1, and then between 1 and 2, so you see this is 1, this is 2. Between 1 and 2, more towards 1, is roughly here, let's say. This is the first point. Again, y equals 0, x equals negative 4.2, so that is negative 1, negative 2, negative 3, negative 4 is over here, and a little bit further than negative 4, it's like 0.2 goes to this side. So these 2 points lie on the x-axis because the y value is 0. And these are actually the intercepts of this equation. These are the x-intercepts because the function is crossing the x-axis. So these are the x-intercepts. Now, the other point, the third one, x equals 0, so it lies on the y-axis, and the value of y is negative 5. So that's, we count and go down. Negative 1, 2, 3, 4, 5. Here it is, negative 5. So this point is also belonging to the function. Okay, let's figure out more points because it's still not clear the entire shape of this equation. So let's figure out more points from it. What else? We can again give simple numbers like 1. Let's give x as 1. Find the value of y. So 1 to the power of 2 plus 3 times 1 minus y equals 5. 1 to the power of 2 is 1. 3 times 1 is 3 minus y equals 5. 1 plus 3 is 4. 4 minus y equals 5. Subtracting 4 from both sides, so you get negative y equals, subtract 4 from both sides, so 5 minus y minus 4. 5 minus 4 equals 1, so negative y equals 1. Now multiplying both sides by negative 1 to make y positive. So y equals negative 1. So when x is 1, y is negative 1. Let's show that on the graph as well. When x is 1, y is negative 1 over here. So that will be here. Excellent. So it looks like this function is coming from here, coming down, something like this, right? But still on the left hand side, it's not it's not really clear for us how it's behaving. Suddenly going up towards the negative 4.2 on the x-axis. How's that shape? So let's give more points near that area to elucidate the behavior of this equation. Let's give it the point -2 to x. So substituting x as -2. -2 to the power of 2 plus 3 times -2 minus y equals 5. So -2 to the power of 2 is +4. 3 times -2, -6, minus y equals 5. So 4 minus 6, that's -2, minus y equals 5. So we have -2 to get rid of. So I'm going to add 2 to both sides of the equations. Plus 2 to both sides of the equation. So you get this -2 gets eliminated from the left hand side. We have -y equals 5 plus 2, which is 7. Multiplying both sides by -1 to make y positive, y equals -7. So when x is -2, y is -7. Let's show that on the graph. When x is -2, which means over here, y is -7. So this is -5, -6, -7 over here. So -2 comes down like this, and -7. This is 1 point. Let's give more points in this area since it's not clear yet. So I'm going to give also x as -1 and find out the value of y when x is -1. Okay. -1 to the power of 2 plus 3 times -1 minus y equals 5. -1 to the power of 2 is +1 plus 3 times -3, that's -3 minus y equals 5. So 1 minus 3, that's -2 minus y equals 5. Now adding 2 to the both sides of the equation to get rid of it on the left hand side. So -y equals 5 plus 2, which is 7. And multiplying both sides by -1 to make y positive and isolated. Y equals -7. So when x is -1, y is also -7. Let's show that also on the graph. So -1 for x and -7 for y. Interesting. The shape is... So I'm now curious to know what's the value of y between when x is -1 and -2. So let's give one more value here, -1.5, to see what's happening between -1 and -2. So now substituting x as -1.5. Let's see. -1.5 to the power of 2 plus 3 times -1.5 minus y equals 5. So -1.5 to the power of 2, the result is positive. 1.5 to the power of 2 is 2.25. You can double check that with your calculators. Plus, well, 3 times -1.5, that's negative the answer. So -4.5 is the answer of that. Minus y equals 5. Now 2.25 minus 4.5 equals -2.25 minus y equals 5. Adding 2.25 to both sides of the equation results in -y equals 5 plus 2.25, which is 7.25. And finally, multiplying both sides by -1 to get y as positive
and alone on the left hand side results in y equals negative 7.25. So when x is negative 1.5, y is negative 7.25. Let's show that on the graph. So right here in between negative 1 and negative 2 is negative 1.5. And for the y, negative 7.25 will be something like here, roughly speaking. So interesting, looks like the function, this equation, the graph, it comes down up to here and then it shifts up from here and it takes up. Looks like then it goes up. But just to make sure, let's also give x as negative 3 to see the behavior around here. So I'm going to give x negative 3 and find out what y will be for that value, just to make sure of the behavior on the left hand side of the graph. Alright, so negative 3 to the power of 2 plus 3 times negative 3 minus y equals 5. Negative 3 to the power of 2, that's positive 9, plus 3 times negative 3, that is minus 9, minus y equals 5. So 9 minus 9, that's 0. So we get negative y equals 5. And multiplying both sides by negative 1, we get y equals negative 5. Okay, so when x is negative 3, y is negative 5. Let's draw that. Negative 3 on the x-axis is over here. And negative 5, we already know where is that. It's here. So negative 3 coming down, negative 5 going left to meet them right here. So now it's interesting. The shape is showing itself. It looks like a U with kind of open hands. So I'm going to connect the dots. And we know this is not a linear equation. So these are curves. They're not like straight lines. These are curves. So that's the shape of this equation. So you see, with this powerful method, we just need to give values to one of the variables and find the other and pinpoint that on the graph to see the shape. On the future episodes, we're going to learn shorter ways of graphing quadratic equations with two variables. So stay tuned. Let me know if you have any questions.